For number one, and all of these problems, what we're going to do is expand out what these exponents are telling us, and then we should be able to condense it down to something smaller. So here, x squared means xx, or x times x, and then x cubed is x times x times x, because the exponent tells us how many of the base are being multiplied together. Now, you can put as many multiplication dots that you want. You can put one, you can put none, it doesn't matter. They're implied to be there. So now we can see, if I look at this all together, I have 1, 2, 3, 4, 5 x's. So this can condense down to just saying x to the fifth, which is a lot shorter way of expressing x multiplied by itself with 5 x's. So number 2 here, we're going to expand out the x to the 7th and x squared. So that's 3, 4, 5, 6, 7. That's over 2 x's being multiplied. Now here we have x is divided by x's, and anything divided by itself, like 2 divided by 2 is 1, or 17 divided by 17 is 1. Or any number a divided by itself is 1. So what we can do then is say this x divided by x is 1, this x divided by x is 1, and there's no more x's that can become 1, so now we can simplify. Well, 1 times 1 is just 1, and then we don't have to write that because we have all these other x's. So here we have x to the 5th over 1 times 1 is 1, but now to divide by 1, doesn't change the value. So x to the 5th. Okay, so for number 3 here, I'm going to start by expanding out this outer exponent 2. That tells us that we're multiplying x cubed by itself one extra time. So we have 2 of these x cubes. Now we can expand both of those out to be 3 x's. And again, this dot I put isn't necessary. I put it there just to visually distinguish the 2 x cubes. Now that it's expanded and it's all multiplication, that whole multiplication can now condense to x to the 6th. So number 4, so here we have to know how to deal with the negative exponents. And the rule is simply that to make an exponent the other sign, in this case to make that negative 8 a positive 8, what we can do is move that base and exponent to the other side of the fraction. So in this case, if we have this x to the negative 8 x cubed, if I want this to become positive, I take that whole factor and can move it to the other side of the fraction. Now, there is no visible denominator, so we can put the over 1 if we like. But then what happens is this x cubed remains on top, and this x to the now positive 8 is in the denominator. So again, to make the negative positive, you take the factor, put it on the other side of the fraction, and then it becomes positive. So now we can expand out and see if we can make some things change. 5, 6, 7, 8. So now we can create some 1s. X divided by x is 1, x divided by x is 1, x divided by x is 1. And now we can simplify this. 1 times 1 times 1 is 1. And then 1 times 1 times 1 is 1. But we have all these x's as well, so we don't need to put 1 and then the x's. We can just say x to the 5th. In case you can't see that, that's 1 over x to the 5th. So number 5 here, to make that x to the negative 7 positive, we're going to take that factor and move it to the other side of the fraction. In this case, that means moving it to the numerator. So this whole factor will move up here, So now it's x to the 6 times x to the positive 7, which can now be expanded out. We have 6 x's, and then 7 more. 1, 2, 3, 4, 5, 6, 7. Got a little scrunch there. But think about what happened. We had 6, and now we're having 7 more. So altogether, that would be 13 x's. Okay, number 6. So the second rule that we have with exponents is that anything to the power of 0 is 1. So in this case, we have x to the 0. Well, x to the 0 is 1. This whole thing here becomes 1. So it's now 1 to the power of 4, which is 1 times 1 times 1 times 1. Now, when you're dealing with numbers, you have to put the multiplication dot. Otherwise, it looks like 1, 1, 1, 1, 1,111. But that is not what this is. This is 1 times 1 times 1 times 1, which of course would just be 1.